Hello everyone! Today I'm going to talk about gas sensing and material detection for everyone. And that's made possible by the integration of our lead sulfide and lead selenide detectors into consumer devices. So when I'm talking about we, who are we? We are trinamiX. We are a spin-off and wholly owned subsidiary of BASF, the world's leading chemical company. We were founded 2015 in Ludwigshafen here in Germany. And actually in the background picture, what you see is the clean room facility that we have here in Ludwigshafen. We're a team of more than 120 dedicated specialists, and we are focusing on two topics, that is 3D sensing and infrared technology. With over 350 patent applications by now and also a lot of granted patents, we think we are an innovation leader in both topics, in 3D sensing and infrared technology. So today I'm going to talk about gas sensing and material detection, but why is that actually important for us? Why is it important for everyone to have a good gas sensing and material detection? Let's look at gas analysis first. Gas analysis is actually a very important topic when you look at CO2 levels. CO2 is something we breathe out. We breathe it out every day. We also breathe it in, but if we breathe in too much, we actually get very tired. And this is important to have just the right amount of CO2 in your air. Because if you try to vent away all of this CO2, so that basically you have no problem anymore, you have to invest a lot of energy. You have to heat up that air that you actually use to vent away the CO2. And on the other hand, if the CO2 levels are too high, you might not notice, but your performance is actually going down, is going to drop. And currently in this pandemic situation, another important factor is that these CO2 levels are actually a good indicator on how much aerosol and how much potential risk of infection is in the air. So you want to know the CO2 level where you are so that you can take measures to improve that situation. The other important topic is textile analysis. I mean, we wear clothes every day, we wash clothes every day. It's an everyday thing, but still, you don't necessarily always know what you're wearing. And this becomes important when you wash things, when you iron things, when you dry things, because textiles can only be treated with certain temperatures and certain cleaning processes. Let's take, for example, cotton. Cotton is a relatively robust material. You can, with certain cotton materials, you can cook them to 95 degrees, no problem. But if you try to do that with silk or with wool or with some mixtures of cotton and synthetics, the results can be quite frustrating and you can destroy your clothes. And for that, it would be important to know what actually you throw into your washing machine or what you're drying or ironing. The third topic is automated cleaning. And I'm talking both about vacuum cleaning, but also the new trend of wet cleaning, of mopping certain areas. For that, your robot, your trusted robot that runs around your house and tries to clean everything, needs to know what it actually cleans. Because it makes a big difference if you try to clean a carpet or if you try to clean some wood or some stone surface. The cleaning strategy for both materials or for the three materials is completely different. But it's not necessarily easy for such a robot to distinguish the materials from one another. And all of these three applications can be tackled with infrared detectors. So let's dive right in. Let's first have a look at gas analysis. So gas analysis, we are going to focus a lot on CO2 today. Gas analysis is ubiquitous, but still there are some problems with gas analysis because you actually want gas analysis to be an everyday item. You want to have that particularly in a battery operated appliance. Because the problem is, if you have to first lay a wire somewhere, if you first have to find the infrastructure to put your gas sensor somewhere in your household, it's actually difficult to retrofit. So while I'm talking a lot about CO2, of course, other gases are important. For example, you want to look at certain pollutants. You want to look at VOCs, maybe some odors, and you want your ventilation system to decide if they want to keep them outside of your house or if you want to let them inside. And all of this should be automated and easy to use. So for easy to use, it's best to have that right on the table, or even you want to be able to carry it with you. Why not have a gas analysis system in your smartphone that you take with you all the time? So if you look at how gas analysis works, it's actually an optical measurement. You take a light source, that's shown on the left side. You have an infrared light source, and then you have a certain volume. And in that volume, you have these gas molecules. And then some of these infrared light that you are emitting from the light source is getting absorbed by these gas molecules. And you measure the amount of light that goes through that volume with a photodetector. Actually, you use two photodetectors. You use one photodetector that measures the overall power from your light source, and the other photodetector measures at the right wavelength where the gas that you're looking at is absorbing. And with that, you can measure CO2, some other gases, methane, whatever. There's quite a lot of gases. Ask us if you have a certain gas in mind, and we can look it up if it works well. So usually what you need is a light source, you need a certain volume, and you need the photodetector. And then this works. But you want this to work with less power. You want to have this working faster, because if you can measure faster, you also need additionally less power. And for that, there is two distinguishing factors. You can either increase the power from your light source, but that takes power. So that you can't do that in a battery-operated application. The other possibility is to use a photodetector that has a very high photodetectivity. Usually what you use in gas analysis systems is thermopiles or pyroelectric detectors. And these have detectivities to the order of 10 to the 8 or something like that. With lead selenide, you actually can have a 10 to the 9, so that gives you a 10 times increase in detectivity. And that, in the end, gives you a 10 times less power consumption than existing solutions. Alternatively, you can trade the volume in your application, the gas volume that you shine your light through. You can trade that actually. So you can have the same power, but lower volume, a lower size of the overall system. Or you can change that with the acquisition time. So you need less time to get to the same resolution. So these are these trade-offs that you can do in gas analysis. But in the end, what it comes down to is you need a high detectivity detector to have some freedom to make these trade-offs, to make these engineering trade-offs. The other thing what you want to do is you want to have a detector that is easy to integrate. Later I'm going to talk about why our detector is actually so easy to integrate and so easy to miniaturize. But the first step is to have a high performance detector so that the overall system can be small. Now I'm talking about textile analysis. So as I said, textile analysis, you want to know what your clothes are made of that you put into a washing machine, a dryer, or that you're ironing. And this gives you improved comfort. You don't need to look at the label. Or sometimes the labels are no longer readable, or you snip them out. But you can detect that stuff with infrared technology. And it improves your efficiency. Why not let your washing machine decide how to wash your clothes? Why do you need to actually make that decision? The machine can do that as well. The same is with the ironing. The iron can do that decision by itself. To achieve that, what you need is, again, a good detection method. And this detection method is in the infrared. So if you look here on the right, we have a spectra, an absorption spectra of different textile materials. And what you can see immediately is that below about 1,500, 1,700 nanometers, it's actually difficult to distinguish these materials from one another. Typical infrared detector materials like silicon that goes up to about 1000 nanometers wavelength, or normal indium gallium arsenide that goes up to 1700 nanometers, actually have problems distinguishing different textile materials from one another, because you just don't have enough features in your spectrum to distinguish, to differentiate the different materials. But what you can see here in the spectra, that above about 1700, 1800 nanometers, there's a lot going on. There's a lot of features. Why is that? The reason is textiles are made of organic materials. And in organic materials, you actually have a lot of different absorption in the NIR that start around 1500 nanometers, something like that. So it's a perfect region to distinguish different materials as long as they are organic. And with the trinamiX technology, with lead sulfide by trinamiX, you can actually use that greater wavelength range to enable a higher sensitivity and get more information out of your measurement application. Basically, you can get the whole fingerprint and not just a small part of it. Same is true for floor analysis. Floor analysis, as I said, is necessary if you want to have an efficient cleaning process with a robot. Who doesn't know the experience? You have a vacuum cleaning robot. It drives around the house and sometimes it gets stuck under furniture. We can't do anything about that actually, but it can also get stuck on a carpet, and we can do something about that. Because the reason why it gets stuck is because it doesn't know that it's carpet. It just drives, and then something gets entangled. So to distinguish carpet from wood or from stone or from other hard flow materials is equally easy in the infrared. As I said, organic materials are easy to identify. And while stone is not an organic material, you can easily say, okay, it's stone or wood or carpet. They have very distinguishable spectra in the infrared. Today, it's even more important to know what the material is that you are cleaning, because we are right now coming from traditional vacuum cleaning to wet cleaning, mopping processes. For that, it's even more important that you know what you're mopping, because you don't want to get the carpet wet. And when you actually clean something like a wood floor, you want to make sure that you have the right amount of wetness, the right amount of moisture on your wood floor, just in order to not flood it or not wet it enough. Yeah? And this is possible with infrared. The reason for that is at, for example, 1900 nanometers, there's a very good absorption band of water. It's extremely strong. And that means with our technology that goes up to 3000 nanometers, you can easily see even the smallest water film on a flooring material. And at the same time, you can distinguish different flooring materials. So it's a perfect match for a floor cleaning analysis. And I've talked a lot about the application itself, but in the end, you also want to integrate it into an electronic device. And at the beginning, I said, okay, it's the performance of the detector, but it's also the means of integration, of miniaturization that distinguish our technology from others. So for the PbS and PbSe detectors, we have developed a method so that you can use the detectors directly on a PCB. You don't need additional encapsulation. You don't need a hermetic package or something like that. You just put the detector on a PCB and you're done. And that is important because it gives you miniaturization on a whole new level. But at the same time, you can harness the power of NIR spectroscopy at a very attractive cost point. So ask us about our multi-pixel solutions, ask us about putting filters on that, ask us about how we can integrate our detector into your application. And we are ready for high volumes. We have a clean room facility running here in Ludwigshafen in Germany with a world scale capacity. and we would be happy to talk about your application. And speaking of which, talking about your application is made possible with our spectrometer. So we have a ready-made spectroscopy solution. So either if you have an application that doesn't need the high volumes, or where you first want to know for yourself how it works, please look around on our booth, look into the spectroscopy applications. We can use the information that you gather there to develop your miniaturized solution, or you have the right solution for your use case already with this spectrometer, which is cloud connected and gives you the possibility to harness the same power of infrared technology that I explained in this webinar. So, happy to discuss with you about your application, happy to answer your questions, and thanks for your attention.